Good morning, this is Ceren Ince. I will talk about the significances of waste utilization for the development of sustainable cementitious materials. Let me briefly introduce myself. I've been working at Civil Engineering program of METU Northern Cyprus campus since 2015. And my recent research falls within the agenda of advanced materials and sustainable manufacturing under the Center for Sustainability. It's a research establishment of the same institution. I am currently coordinating a graduate program called Sustainable Environment and Energy Systems, and you can see we have similar disciplinary research interest groups embedded under this graduate program. My research expertise range from fired clay ceramics to water transport kinetics in mortar masonry systems, but today I will talk about the waste utilization in mortars and concrete experiences that I have been facing for the last 5 years. A very brief introduction. We all know that cement manufacturing is energy and carbon intensive process and is responsible for the 15% of total industrial energy consumption. This is associated with the 5% of the anthropogenic CO2 emissions. If you look at the cement industry's current challenges, they have a rise in the cost of energy supply, the vitality to decrease the CO2 emissions, as well as the suffice to provide the raw materials in the appropriate quantities. So if you look at where these CO2 emissions do come from, they do generate from the fuel combustion, from the process-related emissions, as well as the emissions that generates as a result of the fuel required to mine and transport the raw material. So this devastating adverse effects of the CO2 emissions on climate change should not be underestimated. Unless we bring the net carbon dioxide emissions to zero, we won't be able to case the global warming. And if you look at the current annual emission growth rates, they are twice as large as in 1990s. And the temperature, unfortunately, is rising to approach or exceeds 2% grade according to the Article 2 of the UNF, Convention on Climate Change. And let's see what this means. 2% degrees Celsius would be dreadful enough, and 4 degrees Celsius of global warming would be cataclysmic. So maybe it's now time to change this trend. If you look at the waste utilization experiences that I have, I will show you some of my interesting research results. We'll provide engineering properties. This must be the first priority for us as a civil engineer. And we'll look at the sustainability perspective of these results. We'll look at the current waste management alternatives. And we'll focus on the environmental, ecological, and socioeconomic benefits that we may have through these actions. These are some interesting pictures maybe from the laboratory. I'm an experimentalist myself. Often I do conduct experiments. These are some facilities, and these are the facilities at the main campus. This is central laboratory that we often frequently use for advanced techniques and experimentation. So here I've categorized my waste utilization experiences under groups. I've been looking at, these are individual projects actually. I've been looking at the incorporation of these waste into cement, into lime mortars, into concrete. I won't be able to talk about everything, but I will be calling the most important ones and the challenges that I face and some earnings that we have in the coming slide. My first interaction with the waste was the marble dust. We know that approximately 30% of the raw material actually turns into a waste due to the irregularities during processing. Marble dust is obtained as a surplus from Izmir. I would like to also express my gratitude to Mr. Arsen Angı for providing support for this project. Well, the first results weren't surprising. We try and incorporate marble dust in concrete making. We replace cement. Obviously, if you try and replace a very high oleic binder with a chemically inert marble dust, we get a substantial decrease in the mechanical properties immediately. But we try to incorporate that with the help of pozzolans. We use silica fume, and perhaps we made a matrix, I believe. When silica fume and marble dust were used together, we get a better improvement in the mechanical properties, we get a better improvement in salt crystallization and the freezing and thawing resistance, and we were able to demonstrate these results on the macro and on the micro level that we conducted. The next project, we focused on the waste wood incorporation. We looked at the waste wood fibers and wood powders. And of course, durability characteristics of these cement mortars was our attention. One of the challenges that I think are very interesting to share with you here is that, of course, the first indication is that the wood fibers would be, absorbing a lot of water. They have high water absorption characteristics. But the bundle tube structure of the wood fibers relieved from the microstructure actually gave us an indication that this hygroscopic nature of the wood fibers would serve as an internal curing agent. And this means, in other words, that they would retain water during mixing and they would release it back into the mixture during hardening. Another challenge that we face with the wood fibers were that they had the cellulose and hemicellulose content in their composition, and this delayed the setting time and the associated strength development. We realized in our studies that this effect strongly depends on the amount of the additive used in these composites, and so we limit our incorporation level with 5%, and we got really convincing results. Our next graduate project focused on the waste tire rubber incorporation in concrete, and we particularly look at the long-term study of physical mechanical durability characteristics. Again, as soon as we talk about rubber, perhaps we would just say that this is a hydrophobic material, and therefore we have a poor interfacial transition zone between the rubbers and the cement matrix, which means, in other words, it's not easy to embed these rubbers into the matrix. So some treatment methods must be adapted to make this more possible. We use sodium hydroxide solution to treat these rubbers. You can see this is an untreated and this is treated tire rubbers. You can see we have transformed a smooth, nearly impervious untreated rubbers to a more rough and uneven texture. You can maybe look at different size of the rubbers that we use. This is treated, and you can see treated rubbers actually provided uneven texture with improved surface area, which enabled better anchorage within the matrix. And of course, these treatment methods would improve durability and mechanical properties of concrete. But most interestingly, maybe let me demonstrate these results. Regardless of the treatment technique adopted here in this study, increase in the replacement level of tire rubbers resulted in an increase in the porosity. This result might sound a negative result at the first sight, but this actually resulted in a lower thermal conductivity and therefore indicated a greater thermal resistivity of these materials and perhaps provided energy efficiency in structures. Another study that we finished recently was the incorporation of crushed bricks, waste crushed bricks in lime mortars. We might know that lime has got some poor properties such as high water retentivity, long setting time, and these are often the barriers for this mortar to be used in conservation work of masonry construction. We provided that our results are the water retaining characteristics of lime mortars can be manipulated when we use crushed bricks as a replacement to lime. And this study is not yet finished, but is about to. We also looked at the rice husk ash incorporation in concrete, and this time we conducted a database study and collected more than 1,000 data points from the literature. We wanted to understand the basic factors, the main factors that affect this property, affect this relationship. And these factors constitute our boundary conditions. If you look at some of the interesting results that we have here, when we use 35% of rice husk ash together with some pozzolans, we could reduce the carbon footprint by about 25%. This must be quite fascinating from the environmental point of view. And another project that we are still working on is very close to completion is the incorporation of jacaranda seed pods into hydrated lime mortars. In the campus, we have 193 jacaranda trees. And of course, at a time they fall and make a lot of harm to the environment. I followed the truck driver once and I saw that he was actually dumping the dried seed pods at the back of the campus. This must be a common practice throughout the island. So I collected them and Googled them, and I realized that people have collected them and then made them, some souvenirs and earrings, and that wasn't very interesting to me. My son also joined me to collect the seed pods at a time at the campus. So what I did, I collected them and removed the seeds because I didn't know how to deal with the seeds, and powdered the pods, and I used the pods as an additive into hydrated lime mortars. And the research results are indicating that the hydrated lime mortars would gain an improved freeze and thaw resistance, particularly at the young age. And I think we are all very aware of the Lefke service area, where we have nearly 10 million tons of tailings that are lying around the area and threatening the environment and the human health for nearly maybe 50 years. I collected gold tailings. These are the gold tailing mountains in the area. I collected these gold tailings and used them as cement and sand replacement into my mortar matrix. A fine character, fine particle size distribution, as well as the pozzolanic nature of these tailings made it quite possible to be incorporated in cement mortars. I got a quite good results by improving, the physical properties, mechanical properties. And of course, improving mechanical properties enabled better cost efficiency results to generate from this study. I also collected copper tailings from the same site, and I was able to use them in my lime mortars, and I was able to manipulate the water transport kinetics and attain better optimization in mortar masonry systems. And this is also a very probably happy news in terms of using the tailings in these mixtures. Of course, the use of waste can always be accompanied with the pozzolans, but also we can use type of fibers to also improve our matrix. But the use of fibers also would require careful understanding and characterization. For example, I've been looking at the use of polypropylene fibers, and I realized that treatment methods would improve their surface character and therefore would enable better engagement into the matrix. For example, the cement hydration products now are developing on the treated polypropylene fibers, as you can see. And the curing conditions also must be specific for the type of waste, for the type of pozzolans that we use in our mixtures. So coming to the end, maybe let's throw some challenges and earnings as I am closing up my talk. So I believe that with sound engineering knowledge, we can characterize these waste materials and determine their compatibility, first of all, in the mixture. And of course, pozzolans, the use of pozzolans, particularly their effect at the long term, should not be underestimated. I'm sure together with my results, we can find lots of demonstrations of diverse applications of waste utilization in lime-based materials and cementitious materials and concrete with improved engineering properties. We can show that the engineering property, the strength is improved, the durability characteristics are improved. So this is fascinating from that end. But if you look at the picture from the sustainability point of view, the waste incorporation as a cement replacement, first of all, reduces our demand on the raw material, and that obviously brings our energy requirement and the carbon footprint decreases substantially. When these waste materials are used as a lime replacement, we can reintroduce the lime binder in masonry construction. That would have significant consequences in conservation work. And we should not also forget that lime is the only type of binder that reabsorbs 40% of the CO2 generated during its manufacturing. And that is why we have a sustainable cycle for lime binder, for example. If you look at it again from the sustainable point of view, the replacement of waste materials as aggregate replacement should not be underestimated, as they would result in a substantial decrease in the consumption of natural sources. So this hazard mining, the curing activities also should not be underestimated, as they would result in adverse environmental consequences. I think pictures speak louder than myself here. And Chatham House also stresses the fact that we would require approximately 40% more clinker replacements by 2050 than that of today, because our traditional substitutes are falling. So there's research results together with my valuable colleagues probably reinforces the resources that we can basically implement for the development of sustainable construction materials in the space. From different perspective, if you look at the existing waste management alternatives, such as pyrolysis, recycling, incineration, landfilling, they all have adverse effects on health, on an environment. So perhaps suggesting an utilization of waste material in concrete must be a greener alternative with respect to the existing ones. And we have also lots of research results to accompany that, but probably the time is running. From environmental point of view, these news are appear from time to time. I'm taking Lefke as an example here, and it's very unfortunate that nothing actually has been done much. And Feridun back at 2004 already stated that the concept of industrial heritage could be, simply adopted. It could be simply implemented in the Hopefully we are not very far away from that, so we can rehabilitate the site, help revive the town, improve the tourism, improve the infrastructure and economic development of the locality. So just before I finish, maybe a little comic can relax us down. I concreted his eyes over the garden and then realized I got nowhere to plant any flowers. So perhaps the message is clear. We must move cleaner and greener practices in civil engineering. These are some references I use in my, and I would like to express my gratitude to my graduate students as well as my collaborators and my colleagues at the METO NCC laboratory. And of course, a special thanks goes to the Chamber of Civil Engineers for designing such a beautiful symposium. Thank you very much.